For mic line management, please use the front mic here. I guess that's possible, and feel free, move closer. Yeah, so I think they did the count based on the video codec discussion. I don't know. We have a note taker and we have a Jabberscribe, correct?
We have 2 note takers and a Jabberscribe.
2 note takers and a Jabberscribe. God, you guys are good. And the blue sheets are being distributed right now, so please sign them when they come by. Alrighty. Why is it doing that? Stop. So basically we had the things in blue up here, the things that we've got left, a little agenda bash where we have working group last call resolutions. It's basically all the security issues, so a little bit of, it's probably going to be like 20 minutes for us. And then we have 3 other drafts to discuss, and I guess, Ted, you said we were going to swap some orders, and now I can't remember what we were going to swap it to.
I was suggesting we do return before STP.
So there's a suggestion to do return before STP. Any objections? All right, cool. Cool. Anybody want to add anything else? All right. So without further ado, Martin is here, right? Excellent. I uploaded the version you sent me the link to, Martin. So I guess basically what happened was we put the security arts draft out of the working group with the AD, and then we found some oops, we need to pull it back. So these are the beginnings of looking at them. I just want to point out also that Bernard took all of the open issues that he was aware of when he went through the list and put in the issue tracker. So the hope is that, so there's a whole bunch of things in the issue tracker at the IETF website related to the Rtcweb working group, so we can go through and yeah, we covered this, and just kind of knock them all out.
Oh, I didn't realize I was looking for that.
But that happened.
I looked for the emails. I think I got most of them. Right. Bernard, correct me if I miss anything, and we can go over it quickly.
Where the hell is it? Sorry, I apologize. That's return. That's this one.
Got it in the browser?
Yeah, hold on. As we all go through my email, downloads, it's got to be that one, right? No, it's this one.
Oh yeah.
I have just uploaded this, so it is actually on the meeting manager site.
Yep.
Okay, thanks, Martin.
Next. All right. So it was observed that we don't actually tell people what hash algorithm to use for the A= fingerprint line. So I am going to suggest that we mandate the use of SHA-256 and allow people to use SHA-1 for the near future, though I recommend that we get it in our heads that we're going to turn this off at some time in the near future. It's not quite as bad as it might have been with, say, regular CA certs. We're generating in these certificates and throwing them away on relatively short time scales, and they don't actually carry any significant credential weight. But I don't want SHA-1.
So yeah, go ahead. Sorry, Bernard.
Yeah, so just to comment, my understanding is that existing implementations generally offer SHA-256, but also could validate SHA-1 and SHA-512, I think.
I believe that is correct. I think we might also accept 384.
Okay.
I can't remember exactly.
Yeah, if that's true or some subset of that's true, it might make sense to just say that is what people ought to do, like generate 256, but be able to validate the stuff that people could validate.
Oh yeah, I think the May on SHA-1 is validation only, yes. Russ?
That doesn't make any sense. If it's May only on the validation, somebody's got to be producing it.
Well, yeah, this would be WebRTC compatible devices and
so,
blah, 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 blah.
Anyway, that's not what I got up here to say. But,
sure.
Russ Housley, Vigil Security. Rather than having to do this later document, why don't you say, should not use SHA-1 after some date?
Yeah, this is really different.
I think we only really need to say validate in this context for SHA-1.
So the way I read it, you're saying may do either now,
Yeah.
sending and validation. Is that not what you meant?
Let's just strike sending for SHA-1. I don't think there's any case for a modern compliant WebRTC device to be sending a SHA-1 hash.
Whoa, just a second here. Yeah. That's
No,
not the question. The question is, what do all the legacy devices do, not what the browsers do.
Well, that's why I'm suggesting validation. Let's see if we can get some clarity out of this guy.
This is like the worst document anybody's ever written. Like you really should be embarrassed at how crappy this document is.
Thank you. Yeah, I take full
It's my
responsibility.
document, right? I mean, yeah, exactly. So I guess let's just take a step back. Rather than being sort of boo-hiss about these digests, right? Let's take a step back and ask what we're trying to achieve. So, if we're going to interoperate with older versions, we have to be able to, at least for some reasonable period, both accept and generate SHA-1.
Generate?
Yeah, because those things take SHA-1, right?
Yeah,
And then take
right.
SHA-256. And by the way, like, yeah, I mean, they're probably going to require, by the way, some modification in the JavaScript to like probably strip out the SHA-256, because I bet people don't handle multiple fingerprints very well. But that's at least a JavaScript fix, so no big deal, right?
Yeah, that's probably right too, because of what the 45 whatever it is, 4572
Yeah, so
whatever
we
it
screwed
is,
that because
we screwed that one up. Yeah.
Yeah. So, but I'm trying to figure out what the, what is the, given that there's like been like next to no progress on second preimage attacks on SHA-1, like what's the rationale for like being all negative about SHA-1 right now?
I think the concern here was simply a pre-image attack, wasn't it?
Right, but all the Wang work was collisions. There's
But
basically
a collision in this
progress
context
on preimage.
would be sufficient, wouldn't it?
Huh?
A collision would be sufficient.
A collision in the full certificate, so the self-signed certificates, right, a collision would not be sufficient because why would you generate two certificates with the same digest in different keys? What would be the incentive to do that? So in order to have a collision, what you would need would be a context in which you were using a
Well, if you actually have the private key for the one that you generate a collision for.
No,
then-
wait a second. So in this case, right, the person who's producing the fingerprint is the person who made the cert, right? So a collision attack requires making two certs at the same time with the same fingerprint, right? And so since you're the person doing that, why would you produce one that collided?
Yep.
So I mean, the only case I can think of that would be relevant would be one in which you were using third-party issued certs, and someone somehow convinced a third-party issued cert to give them the same certificate that they gave somebody else. And I suppose that's possible, and I'm having trouble figuring out how that's likely to happen. Maybe I'm misanalyzing this, but I don't think I am.
All right. Well,
If you're going to do the must not later, I think you should pick your dates as opposed to saying, I'm going to redo the RFC.
So back to some of the logic that Eric was starting on, which is there's the stuff you have to be able to validate, right? And so the legacy guy's probably going to send you SHA-1, so you really must be able to validate that. Yeah. If we're going to say that SHA-256 is what you should use by default, you have to be able to validate that as well. And so the only remaining question is, should you force people to validate SHA-512, or should it be something lower, right? So that's validation. And then generation, Eric made the argument they should be able to generate SHA-1 and 256 because that's the preferred one. And I guess the only other question is, should you be able to generate 512? Right? That's sort of my sense. But come up here and tell them exactly what to do.
I don't think there's anything we really need to say about additional hashes in addition to these. You may generate them, you may validate them. At
Yeah,
this point.
I think the minimum interoperability profile. Let's take a step back. The minimum interoperability profile for WebRTC should be SHA-256, and so we absolutely should require every do SHA-256 because we want, and because someday we may have to turn off SHA-1.
And
Generate and validate, right. And in terms of the interoperability profile for older things, that's got to be SHA-1 for now, and I don't see how we can get around requiring that if we want it to work. And so maybe in the future, SHA-1 will be really busted and we'll tell people to stop accepting it, but hopefully we'll have enough warning that people can upgrade their legacy endpoints. But I just like, I would prefer it be SHA-256 only, but I'm just not seeing how we do that in an environment with existing crap that does SHA-1. I think the Cisco stuff does. Now maybe Cisco can change it.
Okay.
We can check into what the status of that is. I don't know, but my guess as an individual contributor is, expect the worst.
And so I will say, if we could convince ourselves that there was only a finite amount of legacy equipment and that could somehow be fixed, I'd be willing to commit to a schedule for deprecating SHA-1. But I mean, again, like absent any, again, may have misrepresented the research, but absent any evidence of a pre-image or an analysis that shows a collision is a problem in this case, I feel like maybe it's a little premature to be like trying to deprecate SHA-1.
All right. Must on both. I think we're getting to.
Jonathan Lennox, so remind me, we deprecated the old rule that's used the same hash algorithm that the certificate itself uses?
No one has deprecated that. I wrote an internet draft on that, and yes, I was about to bring that point up.
All right, so
if you have legacy equipment that actually does that,
I mean, are there in fact rules about what hashes you can use in the DTLS certificates themselves? Because those should align even if we're
correct.
Changing those.
I believe that the recommendation there applies also to the generation of the certificate.
So it's again interop with SHA-1, but must SHA-256 for your own.
I think for the purposes of this, we're going to have to pick one because that's how certificates work, and we have chosen SHA-256. If anyone out there is validating SHA-1 and expects that to also be the same hash that's used in the creation of the signature on the certificate, boom. And I'm not going to be all that sad about that.
Okay.
So we also have a draft that actually says it recommends not using SHA-1 in a signature-based algorithm. So we'd have to, so in fingerprints, it's different between fingerprint and a signature like an assert.
Would you expect that that a certificate with that DTLS if the peer presents a certificate with SHA-1 in the certificate, would you expect that to work, or do you expect that to be rejected?
We don't actually. Okay, so just again, take a step back. The signature that's on the certificate that we present in here is completely immaterial. The only question is whether or not someone's actually doing unnecessary validation on that certificate and choking as a result of what it sees left or right. If there's MD2 in the certificate, I propose we accept it.
I guess here's
if we can,
Sure. Here's how I suggest we resolve this. I postulate that nobody, in fact, enforces this rule about the hash algorithm being the same.
Yep.
And so, unless somebody tells me unless I hear pretty soon that's not the case, I propose we simply remove the rule. And that would leave you. So by the way, you still can even if the rule remains, you have to generate multiple certificates. It just be a pain in the ass, right?
How do you know which one to send?
I would assume the other side would have to match up against one of them, right?
Yeah, but if you've got multiple certificates, you don't know which that the other guy is not validating, has validated the certificate, when at the point that you're offering it in the DCLS handshake.
But that's true in either case because of the because of the EC versus RSA issue.
Well, we can use the EC RSA, the Cipher Suite negotiation to deal with the EC RSA one.
Algorithms too, right? Anyway,
yes.
Sorry, let me move forward. I propose we relax the restriction on having to have the same algorithm, and we remain mostly silent about what the certificates should be signed with. But I say propose to SHA-256. It should be. Yep. But also you're not supposed to check it or something.
Yep.
Although maybe I'd be willing to say you should check it to be reasonably modern because putting in MD2 would not be really good.
No, it's fine. It's just
a
public key container.
It's kind of weird, right?
Do what you want.
I don't
at
think
that point.
I don't think it's insecure. MD2 may be insecure, but I don't think it's insecure in the context of the self-signed cert, which you're not checking. But then also say you must do both SHA-256 and SHA-1 and call it a day.
Yeah, okay.
So we're saying that you can send multiple A equals fingerprint in the same?
We'll have to.
Okay.
We will have to do that.
And we know that legacy equipment won't choke on that?
Sorry.
We don't know that, but we're going to take a punt on that.
I assume it will, but that you can we'll have to patch that up in JavaScript.
Okay.
We'll take that gamble, I think,
I
is
don't
the
like that.
conclusion.
No, we're gonna have to spend the next, Google and we are gonna spend the next like 4 months unwinding this because I know we didn't take 2 fingerprints for a long time. I don't think you do either.
I'm really confused. What DTLS SRTP legacy equipment? Oh, okay.
Here comes the Cisco guy.
And
But also, there's actually a lot of
if you can't, the reason for the same hash rule is if you can't parse the hash off of the certificate, then you won't be able to use the certificate anyway.
Why? No, it's just a public key.
So this is the logic of the same hash rule in SDP, right? Use the same hash to generate the fingerprint in SDP as you did in the certificate itself. So you only need to know one hash function. If you can't read it out of the SDP, then you won't be able to understand it in the certificate anyway.
That's all right.
Cryptographically, it doesn't matter, but it means that you can't actually parse the certificate. You can't.
All right, we got like 6 minutes left for this all of this stuff. so-
Okay, look, I mean, we need to go play with this and test a little bit. Colin Jennings, sorry, as an individual contributor. But I mean, if we're going to break backwards compatibility with equipment that correctly implements the RFCs that we've published, without believing that we need to go and update those RFCs to fix them, I'm going to complain. Like for no security gain, that just doesn't sound right to me. So I mean, I'm game to fix this and make sure that we have it right of whatever we should have done. But,
so to be clear, the primary reason we need multiple fingerprints is not for multiple hash algorithms. It's for multiple public key signature algorithms.
Right.
Okay,
so is there an update to the RFC?
We will take the action to do one.
Yeah, okay, so let's work through this and figure it out. But this is sounding like...
I'm not gratuitously trying to break your equipment.
Right.
I'm willing to go to this effort not to.
Excellent, okay.
The only thing I would add about the SHA-1 is if we leave it in there, we need to put a consideration to say we're using it in a fingerprint purpose, so like leave us alone, security guys. Right? So.
Yeah, we will do that. And I do actually have a draft updating the A equal fingerprint doc that deals with the issue of hash agility and this certificate issue. So I can resurrect that and send it to the list if that's what people want. Right. So this one's fun. I can go through the long explanation on this one. Oh.
No conclusions on this topic, right? Correct.
Apart from we will be going with Must and Much, and we'll work something out and send it to the list. There are a few of us who have the state in our heads. Okay, so Magnus noted this issue. I don't know if Magnus was paying attention to the blogs and various other things at the time that he was away, but this turned out to be a bit of a hoo-ha on the internet, and people got really excited about this exact issue. And we have a bug that's kind of interesting to read. Feel free. Justin will probably have some view on this one. I've got the next slide, which is probably more interesting to people. So we closed this issue before. Maybe we failed to document it. Maybe that's true. Maybe that's an action that we have to take out of this. Notice my proposal doesn't actually suggest that we do nothing. The concern arises out of two things. People are concerned that if they're using a VPN for privacy purposes, we're like spraying their IP addresses all over the internet, and it exposes LAN topology even for users who aren't concerned about using these VPN devices. The concern is that the browsers are unable to properly distinguish between what is a network where the topology should be hidden and a network where the topology is simply, how the topology is. And people who are on, say, a normal VPN really do want, in a lot of situations, to be able to use their local network to make their phone calls and whatnot, and don't want to pay the price of tromboning all of their media traffic all the way back home. So we have a problem. And the other point here that has been made a number of number of times that people seem to not appreciate very well is if you actually care about your privacy, you actually have to take considerably more steps than just turning on a VPN. People don't realize this, but you know, when people ship Tor, they turn off things like WebRTC, right? Because they understand exactly this sort of, and they turn off JavaScript. I mean, yeah, I mean, a lot of things are needed in order to get proper privacy protection for these things. And my proposal here was to leave this to the browsers, and Magnus notes that we should probably document the fact that we are doing so. Justin.
So I think the thing that we missed in the first go round on this, or at least I missed, is you know, we all kind of knew that the local addresses would be surfaced to the browser, but I wasn't aware of the fact that if you're in a multi-home case, or like, you know, you have multiple active routes, that you can actually, you know, send stun out that second route. You know, if you have a VPN tunnel, you know, you actually might have stuff going at the public IP stuff, and you might find out the public IP, which is distinct from the, you know, the VPN IP, and that's what people really got upset about. And so the fact that you'd have like this multi-home situation, I think that's the thing that might be somewhat novel since the last time we talked about it. Now, back to the, you know, the original part, like should we have turn-only mode? I don't think you have to go to that extremeness, because really the main thing you want to do is make sure that nothing is surfaced to the outside other than what the, you know, web server could already see. And so what we did in Chrome to solve this was basically have a mode where when you bind, you don't bind every interface, you just bind to the any address. And so you can still get stun candidates just fine. You can still get turn candidates just fine, but you don't have to limit yourself to just turn candidates. It's just you don't give out any local IPs, and you don't give out anything else that wouldn't be found through going through the default route. And so what I would suggest with this document is that the solution that, you know, if people agree this is a good solution, we kind of document this as like, you know, if you know, there are trade-offs, but if this is something you want to sort of optimize for, this is the approach that we recommend.
All right, so I just want to jump in. We have 20 minutes allotted for this. We're going to keep going, though, and kind of shortchange the non-working group drafts at the end, because I think this is more important than we drive these home. So go ahead. Sorry, Harold.
Hi to all, this John. Just mentioned that in the reports I've seen, there's one single VPN product for the Mac that causes the local address to be revealed. I have not seen it happen with any other VPN setup. It's nice to be in a place where people don't go on a wild panics about this.
So I think that Justin had the right take on this. That we so my slightly more concrete version of Russell's proposal is we should document the state of play, and document what you could do in order if you wish to care about this, and say browsers may wish to supply some mode which you get into in an unspecified way that that behaves the way Justin just indicated. That I realize that will not please all the people who wish we just turn off WebRTC by default, but the people are not going to get what they want. One thing I would also mention, as Cullen mentioned this to me privately, is that my understanding is that most organizations which care about security and run VPNs also strongly discourage running these dual home VPNs. And so we really ought to, I mean, if we can find some guidance that says don't do that, like that would be useful to put in the document to point to say, like, this is, you know, the browser can help you out, but basically this is because your system is configured in a way we don't advise.
Ted?
Ted Hardy is an individual contributor. I am generally okay with the idea of making this a descriptive text. I am concerned, however, and I don't care whether we deal with it here or in the WebRTC context, about making this something that the user has to find the invisible control for on page 3 of the about : thing. And so I would suggest that as part of this text, we say, here are example cases where it should be the default. So if, for example, we believe that private browsing / incognito mode or the related things is a place where this should be the default, that would be useful to do. But if the chair wishes to tell me that I should take that to the W3C, I might agree.
I think I could probably support that notion.
I would, Justin Huberty, I think I'd just be a little careful about that. I think the notion of private browsing is that you leave no trace, not that you're not identified to websites. In fact, it even says something like that when you go into incognito mode. And I just, we shouldn't overstate kind of what incognito mode actually does. You're not invisible. I think it's fine if you're using like Tor or something else where you're explicitly privacy preserving, but like let's not overload the meaning of like incognito.
So, I mean, we sort of bandied about at one point actually suggesting a standardized affordance for the VPN to tell you, like, that you should kick yourself into this mode. I don't think we should, I certainly don't think WebRTC should standardize that such a thing, but like, if someone came up with some affordance for that made some sense, I think we'd be willing to listen to it. But I don't know what to do with that other than that, right? I mean, I don't know what it'd be, like the DHCP option, or you resolve MI in incognito mode, that example that invalid or something. But not incognito mode, VPN, hiding mode.
Ted Hardy again. I understand the concern that Justin raises. However, I think that this actually is sort of the broad question of when somebody is making use of one of these and you have this sort of weird, you're leaking things you would not necessarily expect. And clearly when you're browsing, even in incognito mode, you are leaking the IP address from which you are browsing. There's kind of no way around that, right? Leaking other addresses, some of which may give a great deal more information in this context, I think means that if we're not going to have a relatively clear affordance to say, here's how you turn this on, then we're going to have to infer it in some way. And if he's opposed to inferring it, fine, cool, then I think we should send a message over to our brethren in WebRTC that we would like an affordance for this.
So, Colin Jennings, an individual here. So first of all, I think this only happens in split tunnel VPNs, which are highly not recommended by anyone who, for any reason, for the most part, right? So I think this is a corner case of we're trying now to patch up a bug that somebody else introduced. And if that causes problems for you, don't do it. The next thing I'd like to mention is that if you expect privacy, you're going to have to be running an application inside of your JavaScript here that is focused around providing you privacy. And that application can easily strip any addresses it feels are inappropriate out. It could remove all but the turn addresses. So the application itself can do this. It's just not the browser is going to guarantee it for you at all. And I don't think this is what private browsing mode was meant for at all, to respond to that. In fact, one of the biggest use cases of WebRTC that's actively deployed today involves something that's mostly done in private browsing mode. This is these web interface things. So adult cat finder, right? It's not that's not linked to that type of privacy. So I just don't think it'd do that. The other thing I was going to mention was do with the default addresses. The default route often takes you out a interface that makes you very sad in many circumstances. So I would not be in favor of seeing an algorithm where you had multiple interfaces that were all live and you only use the one that had the default route, because that's often not the one you want.
Adam Roach, I'm going to ignore that because it's making my head hurt. I wanted to agree with the assertion that private browsing mode doesn't mean this, but I wanted to add on that I think the real salient point here is up on the slide, where we're pointing out that real privacy protection requires a lot more than just making sure people don't see your other IP address. And giving users the illusion that we're doing something magical by fixing this one tiny little aspect of protecting where they are on the network is doing them a disservice. You really need, if those people are concerned about that, you steer them towards something like Tor browser that is going to sort of take care of all of that for them, because having users try to piecemeal this together is giving them a gun without any instructions, not even telling them which end is dangerous and saying go.
All right, we're going to give Joe the last word on this issue.
Just generally, I think that, I agree that we should have this not buried on page 7 of the prefs. I think it should be like a top-level privacy pref. I think it should be off by default. The optics of this are particularly bad. It makes WebRTC it hurts the brand. So I think that, making this have a standardized way to do it and making it prominent in prefs is a good way of doing it. Doing it in incognito mode, I don't think is a good idea, because the fact that you're going to be trombone routing when you're in incognito mode versus in normal browsing, that's hard to explain to people. Those type of behavioral differences are not what one would expect. Yeah, that's it.
Jonathan. First, Colin, I was perplexed why you think that the default route doesn't work because I don't see how you reach the web page in the first place in that case.
Through one of the other routes.
Well, then,
Yeah, okay.
but that's not how TCP works.
That's another issue.
But anyway, but I think, also the application can do it answer isn't the right answer because the threat model here is the hostile JavaScript that calls create peer connect or calls create offer in order to enumerate your local IP addresses. This is not you're trying to use an application that provides privacy. You're hitting some random web page that is using the WebRTC APIs without you knowing they're doing anything WebRTC at all to enumerate your addresses.
No, let's be clear. This is because people are using VPNs to get to Netflix, and Netflix can now see where you actually are.
Or, I mean, is there also you go to, the Chinese government site, and therefore they see you're using a VPN to reach Facebook?
Something
it's the
like
same
that.
threat model, right?
Yeah.
I don't know if they're doing it, but.
Joe Hall, CDT. I still don't fucking understand WebRTC. I'm sorry, so I'm going to say some naive stuff right here. I think what you're seeing in the internet wars on this particular topic are you can land on a page that has no indicia of being a signaling server, maybe that's the right word or whatever, that throws some JavaScript that then exposes that. And folks like us go to some great lengths to make sure the FBI has to do some pretty crazy stuff to get access to to local IP and stuff like that. So I don't know what to do about that, and this may not be the place to do anything about it. But that's just the qualitative sort of.
All right, guys, we got 2 more issues, so.
All right, good feedback. Next.
Bernardo, I think we should move on.
Yeah.
It's the right way to explain exactly what's going on here. It's kind of complicated. Depends on how the VPN sets the default routes, blah, 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 blah. Let's talk about it on the list.
Let's have someone propose some text and work from that.
Okay.
Amusingly, Randall Jessup just did that in the Jabber. Browsers should, capital, provide a way for users to suppress interfaces from being visible in WebRTC. The details are left up to the browser.
That would be satisfactory to me. Was that satisfactory, Justin? Yeah, so I think let me try. I think Justin described pretty accurately what you would do if you cared about this. And then we should describe that text, say, we don't recommend using this kind of VPNs. With that said, browsers should probably know forward and do the thing Justin just said.
All right.
I think I can produce that text to work.
Someone can produce that text, expanding on what Randall just shared, and we'll move on to. Oh, yeah, this one's easy. There's a bunch of Estes residue in the draft. We'll just remove it.
Wire it in.
So,
I think Magnus identified a couple of points where it was just
yeah.
stuff that was obviously a holdover from the time when we weren't certain about whether or not it was Estes or DTLS SRTP. Right. Easy. Next. Yeah, something. Well, we can blame Kaufman for this. We still have to remove it. Next.
That is it.
That's it. All right.
So Bernard also submitted a bunch of issue trackers occur, so in the wiki, so that we probably need
I
to
went
go
back
through.
over the list. There are a couple others. I don't know that we have to go through all of them, but basically there was one issue on SRTP MKI, and I think everyone agreed that nobody's implementing this in WebRTC,
Do not use.
but it's not in a draft, so we should
Yep.
say that. I think there was another one. There were other ones about.
That's because they're on other discussions.
Yeah, Eric summarized what happens with respect to renegotiation and existing implementations. That never
Yes.
made its way in.
Do not use.
Do not use. I think there was some questions, about DTLS allows you to potentially set up one association and use it for both RTP and RTCP, and the agreement was nobody does that either. So that probably should be in there. Don't do
Do
that.
not use.
Don't do that.
Of
It would
course.
be like in the non-MUX case, trying to use one DTLS connection to key both, and the answer is don't do that. But it is allowed in 5764, so there should be something that says don't do that.
That's kind of crazy. Yeah.
Yeah, it's in 5764. Anyway, we can go through the other remaining ones.
Yeah, I don't think any of those sound controversial. If you think any.
Yeah,
any of
they
them
were
need
all just
discussion, we'll
about documenting what in fact everyone already does, but just shoving it in there so we can say, haha, don't do that.
All right. Okay, great. Thanks a lot, people. Now we're going to move on to the RTC transports draft. Harold. Thank you for standing in the box, Martin.
It's such a long way. Okay, transport. I think this is very close to being finished, mainly because nobody is yelling at me about it, hardly. But there's been some changes in the last 6 months. And there are a couple of changes more that I want to make. I'm not counting minor and textual clarifications that I'm just doing because Magnus reviewed the stuff. Thank you. But these are actual technical changes. 7 to 8. Next slide. HTTP proxy had a reference for HTTP Connect saying, yeah, you should support this. -8 has instead a reference to draft IETF HTTP channel protocol. That means that it should be shorter and clear what it exactly it does. It also downgrades the requirement to a may with based on the discussion at the previous IETF that more or less said, well, all the browsers are going to do it for commercial reasons, but we shouldn't force everyone to do it. So, may. But I messed up the edit. I lost a couple of references to, yes, you need to support proxy authentication. And I'll put those back in. So that should be uncontroversial, I think. Next slide. The one that I thought was controversial, but wasn't, at least when on a mailing list, was the bundling thing, which is that if you're mandating something in this document, then JSEP has to say how you signal doing that thing. And JSEP says that balanced bundling mode is you propose one bundle that can have everything in it, but you mark most of the stuff, mark the complicated stuff as if you don't understand bundle, just don't look at this. So Transport 07 indicated that there's a mandatory configuration that says all the video is bundled in one transport, all the audio is bundled in another transport, and all the data is bundled somewhere else. Since JSEP doesn't offer a way to get there, we shouldn't make it mandatory. So I changed it.
Magnus Westlund. I mean, I do like that mode actually, because I think it has some usage when you're trying to apply flow-based QS on it. However, and I think it's actually this decision here to make about, it's not about which spec you want to change. We actually want to specify in JSIP how you do it, or removing it from transport. That's, I think, is more fair description here. But yeah. So, I mean, I understand that as long as you have any multi-stream, if you remove this, we lose the capability of having multiple media streams or media sources being bundled together on one flow.
No, we don't. We lose the ability
per media type.
By media type, yes.
Yeah, yeah.
Or we lose the ability to mandate that all browsers be able to do this. Yeah. The draft still says that it may do this. And the reason for the change was I raised this on the mailing list. I got comments from Ecker and from Justin saying that this is the way they thought it should be. No other comments were received on the list, so I acted in the assumption that this represented the consensus.
Jonathan, I mean, my impression was, mostly from talking to Peter rather than actually reading it, is that the 1.1 APIs will have APIs that can support multiple bundle groups. 1.0 will not, so defer to 1.1. I think it's a useful feature, but not a world-breaking feature if it's not present. So 1.1 seems like a fine place to do it.
I will not promise anything about 1.1. Transport is controlled by JSIP, and JSIP is transport should be consistent with JSIP, and JSIP should be consistent with the API. That's the layering as I interpret it now. No promises for 1.1.
Peter Thatcher. So there are two separate things here. One is what the policy does when you call create offer, what SDP it spits out. And the second thing is what SDP is allowed in set local and set remote. So if we allow multiple bundle groups in set remote, then you can still have bundled over audio bundled over one transport and video bundled over another transport, regardless of the policy issue. So the real question is, do we support multiple bundle groups or not, which is what we talked about yesterday, and it really doesn't have anything to do with the policy, because you can always do it even if the policy doesn't make it easy.
So, Colin Jennings, I mean, my understanding is if we sent it, and this is building just what you said basically there, what Peter said, if you get an offer coming in that supports multiple bundle groups, supporting bundle requires you to be able to support that. And we would expect something reasonable to happen, including the possibility of negotiating all those. From a transport point of view, we can clearly have more than one bundle. Okay.
The decision I heard in the room yesterday when we discussed bundle was that it was allowed, specifically on a question from our friends at Mozilla, to reject all but one bundle group. I'm happy to revisit that one, but what? Yeah, accept the M-lines, but accept only one bundle group.
Right, so I don't think there was ever a decision consensus on yesterday. That was where the discussion was going, which seems to be a reasonable thing. But it would certainly also be possible for them, I thought we were discussing the other day, for them to, when they got this offer in from some non-WebRTC device that had multiple ones, they may reject all the bundles. They may accept one of the bundles. They may accept more than one of the bundles. Right? That's what was the discussion. I think everybody was on at least agreement of that. There was disagreement of whether there was APIs that would cause you to create multiple bundles in a browser. I'm leaving that issue alone right now because I don't think it has anything to do with transport.
Yeah.
But so I think transport certainly has to allow for more than one bundle.
Yes, it says may support. I mean, the text says that you must support a mode where everything's bundled together, and you must support the mode where nothing's bundled together, and that you may support other configurations. That's the current text.
Okay, so does that have any inconsistency with JSON then?
So the text now has no inconsistency with JSON. The text in version 7 had an inconsistency with the current text in JSIP. That's why I changed it.
So yeah, Magnus Westlund. Yeah, I'm fine with that as long as it's possible, and I think, but that possibility to some degree needs to be reflected up the stack also to some degree, sufficient degree I would say, that you actually have some chance of actually using this. I mean, yes, I can understand if some implementation at this point doesn't support it, but...
So, as I understand it, and Justin can correct me if I'm wrong, the JSET bundle processing rules mostly apply to the offer. So imagine, so someone sent you, some non-JSEP endpoint sent you a bundle offer that was done the way you suggest here, namely audio in one tranche, in one bundle group and video in another bundle group. You could accept that regardless of what the bundle policy you've been set for was, correct? Because it only affects bundle only, not the bundle group assignments. And so I think that so it certainly ought to be the case that browsers should be allowed to and encouraged to, in fact, accept those accept those bundle group offers. Now, I'm not going to argue at what level 2119 order of strength it should be, but like I consider it kind of a deficiency that we only accept the first one, and we probably should get around to accepting more of them. Though I don't know, that's a huge deficiency, right? Not a non-compliance, but a deficiency. The relevant question for me is, do we need an API surface for the offer to control bundle group assignment? And I think that's where we ran aground the other day. And as I understood Cullen's argument, it was that that because bundle groups are tied to transport parameters, and so are QoS settings. If you have differential QoS settings, then you must have a necessity put differential bundle groups. Is that correct?
And I don't know if I want to go into it here, but yeah, I think that was, and I shouldn't have used QoS, I should have used priority settings. The priority stuff that we're doing, that API would, if you had some video at one priority level and some video at a different priority level, we have agreement in the working group to add that. We don't have a pull request because we were waiting for the doohickeys to get in first before we could send the pull request. It was one of the driving cases for adding the doohickeys. Yes, we're going to have a pull request on that, right? No, we don't have that.
So maybe we do want to take this separately, but I'm just trying to put my head around this interaction, because presumably, what would happen? I mean, say we had a pull request for that, would I be able to fob the priority settings after the connection was set up, and would that require any negotiation to debungle things? What would our set? I mean, say we have everything bungled into one group, and then I say, well, actually, audio should be really high and video should be really low. Does that mean I have to debundle and do a read handshake to debundle, or would that be forbidden? What's your thought on that?
I was assuming that stuff was set when you added the tracks or whatever, but I mean, it doesn't. I don't know what happened. It changed. You'd have to reoffer.
Yeah, Justin Birdie, I'm just really that sort of makes some sense, but it's a sort of implicit API. They were saying like debungle or bungle these things based on something that's not just about bungling. And like my main concern here is that we're going to need API surface that's not as simple as a policy. We've talked about, well, you can bungle audio and video separately, and like that makes some sense. But Colin has also talked about this sort of notion of like I want to send thumbnails in one bundle and main video in another bundle. And so like I think the API surface is going to be much more detailed here than any simple policy setting. So I think we could, for the 1.0 set of things, we could still have a lot of things still to figure out in this. My general feeling is that we should just tolerate whatever we receive, but what we generate should be very simple.
So we cut the line. Sorry, I meant to say we cut the line, and I didn't want to interrupt him, but we're cutting the line at Peter. So the two of you who joined after Peter. Lo siento, amigos.
Okay. Adam Roach, I'm mostly getting up to agree with Justin, I believe, where I think that right now we shouldn't worry too much about what the W3C will do for subsequent versions of this, and we should leave the door open for accepting those things, good, but not say anything more than that.
Peter Thatcher. I was just going to point out that in the W3C world, this could all be solved not with a policy, but rather with RTP sender.setTransport, because then the JavaScript could do whatever it wants, arranging the different things. And if you were crazy, you could even make that fire on negotiate needed and have bundle groups appear. But it would be effectively one method that would be very flexible rather than a complicated policy. That's one possibility.
Thank you. I think the conclusion from the discussions, as far as we have a conclusion, is that that the text in -08 seems to say roughly what we wanted to say, but that there's a huge amount of uncertainty, and people need to go back and read JSEP and transport and bundle all at the same time and suggest changes on lists. By the way, this draft is now on GitHub. GitHub is a very fine place for suggesting text. I mean, many people have figured out how to suggest text on GitHub. Yeah. Okay, so next slide. This is the next slide. We're now on changes I have not made, but I want to. or I want the group's advice on how to deal with this. There are two changes. One of them is whether we should reference Ben Schwartz's return document, which is corporate turn proxies.
So we actually have that later in the meeting, the consideration of that draft.
I'm happy to leave it to take the conclusions from that discussion.
Okay, and since we actually want to get to that draft, we have to speed up a little bit. So for the next one, please raise.
Okay, next slide. Okay, SRTP DTLS over ICE, 5 tuples. This is just after reading through the DTLS document and the DTLS SRTP document and seeing what text they used, I came up with the following note to add to the text. Basically saying DTLS SRTP as defined in RFC 55764 defines protection of data carried over a single UDP source and destination port pair. In the context of using ICE, the term single UDP source and destination port pair needs to be understood as a single ICE component, as defined in RFC 5245.
Justin Uberti. So 5763 is actually very clear and explicit about how this stuff is supposed to work. And it says actually the right thing. 5764 has a little bit of ambiguous text, but really 5764 doesn't talk about ICE at all.
That's the bad thing about it, yes.
Yeah, I mean, but I think the main thing is like, you just say, look at what 5763, I forget what the section number is, but it says exactly how this should be handled. Instead of talking about 5764 even at all. I'm actually have some slides for MMusic tomorrow that's going to talk about this specifically.
Okay, can you send text?
Yeah, absolutely.
Yeah. What Justin said, and in addition, right, realize single ICE component is only one side of it, and if you have forking, this doesn't work. So,
forking?
Well, if you have forking, then you have multiple ICE transports, right, all with the same component, because the component only refers to the offer, right?
No, components are
Only one side.
at the transport level. Components are scoped by the ICE connection, by the ICE.
In 5245, if you look at the definition of component, it's like one. It just refers to a candidate.
Oh, if you connect to two different places, they have two different components. Okay.
Keith? Oh, yeah. That's it.
Okay. And that's all we have. I mean, Ecker, if you tell me where to send text, I can send text. And until we have a change in the reference, I would like to keep this text here. Okay.
So Keith Drake here. I just wanted to express a concern that you're inviting the entire IETF discussion apparently to go to GitHub when the official means of communication is the IETF list, or the list for this working group. So at least issues of a discussion nature should make their way in some form to the Rtcweb working group list, not just hide on GitHub.
Yes. Yes. Text suggestions are good on GitHub. And it also is a tool I use to keep track of what I remember from the mailing list.
So
but yes, discussion on the mailing list.
Yes. And you can suggest on the mailing list as well, but the discussion will remain on the mailing list no matter where the text suggestions are made.
All right, Ben, you're up.
Thank you.
Hi, I'm Ben Schwartz, and we are short on time. Let's go.
Yeah.
These slides are going to look really familiar to a lot of people. So return 5 is the same as return 4, but it's got new figures, it's a little bit easier to understand, it's a little bit clearer, and it has this nice extra discussion about handling these multi-tenant cloud turn servers, which is an interesting use case. And thanks very much to Alan Johnston and John Yoakum, who did a very detailed, thorough review to help with this. Next. Okay, so this is the same as always. The turn server is normally configured by the web page, but with this argument to RTC peer connection, and then you get your relay candidates, and there's lots of good reasons why you might want to use a turn server if you're in an application. And it looks like this. This should look familiar. You get a host candidate, maybe you get a server reflexive candidate, maybe you get a relay candidate from the turn server. You speak different protocols to them. So we actually have this requirement in what is now actually an RFC that the enterprise turn servers have to be somehow integrated into WebRTC, but we've never actually clarified how they're integrated. Return is designed to pin down exactly what it is that you're supposed to do if you happen to find yourself with an enterprise turn server. So we have, these figures are basically Alan's figures adapted from ASCII art format into slide format. So suppose that you had a turn server that was somehow basically in the DMZ. We'll call this a border turn server. It's somehow associated with your network border stuff. Then you could get a candidate on it potentially if you knew about it. And it's marked as, I've marked it here as a border candidate. We've somehow gotten it from this turn server, but next slide. We don't know what to do with it. But we might really want to use it because in some cases the firewall will actually block all of the traffic that you wanted to use to the application turn server, for example, or to use the server reflexive. So on those networks where the network operator has blocked UDP in general, but has allowed it to authorized users via the enterprise turn server, maybe for quality of service reasons, who knows. We would like to be able to use that candidate. So, but to do that, we need some idea on what to do with it. Currently, we can't even assign it a type because we don't have any standards to define how to handle such a thing. So that's return. So return explains that what you're supposed to do if you get a candidate off of some enterprise turn server is that candidate actually should act like a virtual network interface. So to be clear, this is not just taking that turn server and dumping it into the list of turn servers along with the application turn server. Instead, it's a little bit like a VPN. It's a lot like a proxy. So next slide. So if you think of that as a proxy, then what you actually want to do is you want to open that port and treat it as a host port on a new virtual interface represented by that turn server. You might even want to do stun over that interface, although in most cases that's actually redundant. You don't really want to do that. But maybe you do it and it's irrelevant, doesn't hurt. And you, most importantly, want to connect through to the application provided turn server in case the application really needs you to be running through that turn server. For example, because it's trying to hide your identity from the other person that you're talking to. Or again, for quality of service or routing control reasons. In order to do this, you need a double turn connection. You're actually tunneling a turn connection to the application turn server through the enterprise turn server. And there's no problem with that. That doesn't require any change to turn. It just is a strategy that the client needs to use if it finds itself in this case. Next. So we call this a proxy. It's very analogous to the classic kind of web proxies that we're used to. I'm not talking about the awful inline proxies that are messing with your traffic. I'm talking about the auto-discovered proxies, like the things that you find in the web proxy auto-discovery protocol, which has been around since 1999, or the things that the user configures through their operating system or something. Okay, next. So, right, so this is what an HTTP proxy looks like. It lives in the DMZ. You somehow find out about it through some auto-discovery protocol. Your traffic is actually addressed to that proxy, and you speak some protocol to it to make it make connections on your behalf. And that's exactly what we're talking about here for turn. The only difference is TCP versus UDP, basically. So there's one interesting case that Alan and John found while we were talking about this. What if, hypothetically, your application had a contract with a cloud turn server provider that was providing their turn server and wanted all traffic to go through it, demanded that all traffic go through it, and your enterprise network that you were on also had a contract with the same enterprise, same cloud turn server provider, and also demanded that all traffic go through that. Do you have to go through once or do you have to go through twice? That's right. I guess you could do other interesting things. So we thought about this and decided that you actually, next slide, you actually do have to go through twice. And the reason that you have to go through twice is that potentially the authorization is independent for these two things, and you can imagine, for example, a cloud provider giving statistics back to the people who are paying for the traffic. So those statistics could easily include the IP addresses that are being used to connect, and so essentially to preserve user privacy and get correct billing, you need to connect twice, as if the turn server is independent. But if we can come up with a way to avoid this safely in the future, in cases where the authorization or the origin attributes work right, then we don't have to do it.
Yeah, Martin Thompson, I think this is an okay conclusion. If this turn server wants to do something special so that it doesn't have to send packets to itself, just realize that these two things are the same internally and optimize that out, that's fine.
Right. So I think that anybody who deploys cloud turn server should be really excited about this conclusion. I don't know what you're referring to. Anyway, okay, so in conclusion, return hasn't changed. It still gives us precise description of how we're supposed to meet our requirements that are already documented, but now we have nicer figures, and hopefully it's all a little bit clearer.
So Colin Chase, I asked on the list, but one of the questions was about how we discovered these. And I think that this has huge security implications on what the answer is. I think we definitely need to answer that fairly concretely.
Sure, I'm happy to talk about that.
So what's the answer?
The answer is, the answer is, I think it's actually out of scope. I think it's irrelevant. And tram auto discovery.
Okay, so I do not think it's possible to analyze the security properties of these, and more specifically whether this is going to be used to man and middle my traffic, which is a major concern in the security and analysis of security documents at IETF. And so I do not want us, I think that issue needs to be answered in a concrete way in the documents before I can decide whether I think that we should reference this document or not.
This document cannot and will not include the auto discovery or discovery mechanisms because the TRAM working group owns that.
It's fine for it to reference the TRAM working group. I'm not saying it has to be done, you're sorry, you just said that it won't reference the methods?
No, it can't,
right.
It can't.
It wouldn't be in this document is what you mean?
Yeah.
Okay. So, the methods they're proposing over there right now would be a big security problem for us. They'd be much worse than the stuff we were talking about with split VPNs a minute ago, right?
So
they allow anyone to take an attack and move it over, right?
Yeah, but this is exactly parallel to a long-standing and universally deployed system.
No, it's not. It's not the same as the PAC files.
Yeah, I think it's exactly the same as PAC files.
You want to say something about PAC files?
Long-standing bang equal well below.
So I think we could talk. I think we could talk about how auto discovery works in the context of security documents. But as Ben says, this is really orthogonal to that. This is saying if we find one of these things, here's what we do with it. I think we should treat that separately and decide as a working group if we find one of these things, is this the right way to handle it?
Okay, so I'm pretty categorically against putting in something that may allow random people at the Starbucks to man in the middle of all my traffic. Now, the proxy.pac file is somewhat different. If we said that was going to be the method we used for this, and we also described my second question, which is how do we get the credentials to use these servers, which I got a complete blow-off answer of, oh, you just use the enterprise credentials. I mean, how does that really work in practice? We're going to need a lot more specific than that.
I guess we can keep going, but we are over time.
Alan Johnson. So this is really just about how we can get two turn servers in a given, into a single candidate effectively and make it work. And we need that to happen. Otherwise, when we get behind an enterprise system, WebRTC is not going to work very well. And this is the solution for that. And if there are security issues, we need to work through some of those. But also point out that this is for cases where people control the network. So if you're talking about being able to route packets to a turn server, in an enterprise, they can do anything they want to your packets. So there's really no difference there at all.
Ted Hardy, first, they can't do anything they want to my packets. They can drop them at any moment, but not at anything. Can you go to the slide that shows the double turn?
That one?
No, keep going back. There we go. So as I understand it, the border turn proxy, there's a now invisible dot that represents the border turn proxy, which is now forwarding the the traffic through to the turn server in the cloud. Is that correct? Okay, so there's like a minuscule dot missing there. And the theory is that in this case, the relay 2 candidate is turn in turn, right? And so how is it that the browser and application contexts know that they are to generate turn in turn?
The application, depending on your definition, in the JavaScript sense, is not.
Sorry,
none of this
you're
is
quite
exposed.
correct. I apologize. That was I meant the browser or mobile application using a browser substrate. Sorry
Sure.
about that.
So the answer is that it's up to the browser to determine what is a trustworthy mechanism of accepting a turn configuration. For example, you could imagine a registry setting that allows an enterprise to, just exactly the same as proxy configuration, to set an operating system setting that adds a turn proxy alongside its HTTP proxy, so that UDP traffic can exit the network in the same way that allows TCP traffic to exit the network through that HTTP proxy.
So in mobile devices, then, am I to understand that in a mobile device, this OS setting would be present at all times?
The Android, I'm aware of Android. Android has a user-controlled operating system setting for setting an HTTP or SOCKS proxy. It's got a GUI. And it would be, in that case, up to the user to set that.
Okay. So
I imagine most cases you wouldn't want to use the same proxy at all times. I think that's probably what you're getting at, and I think that this will probably be discovered from the network via PAC or some similar type of mechanism.
So given that, let's assume that there's a case here where there are a number of fragilities in introducing this, in addition to the potential optimization. So as I understand it, you believe that there are going to be enough cases here where the NAT firewall will simply block the UDP outbound traffic unless it's going to a turn server, that RTC will have no effective candidates because it won't even be able to reach the turn server in the cloud, much less be able to send direct connect. So I understand that that's the motivating example here. I think the problem I'm having, and I think maybe a generalization of the problem that Cullen raised, is you can't solve that case by introducing fragility into other cases. And so I'm a bit worried about the case where somebody who has such a setting starts to send turn and turn to the turn server in the cloud, which then goes, I have no idea where to send the turn inside this.
I don't follow. It's not, yeah, it's
bold words, Justin.
It's
never ambiguous.
It's never ambiguous. The application provides a set of turn servers. Those are the terminal turn servers. As far as the application is concerned, that's where the application data is exiting.
But so I do think about the web proxy, but there are two different kinds of web proxy, and there's a web proxy where you actually expect the proxy itself to behave according to a set of rules, and there is a web proxy where what you expect is that it's told to connect and it's a pass-through for certain kinds of traffic. And what I'm hearing you say is actually that you expect turn in turn here, which implies to me that the one element of this term will be interpreted by that proxy before being passed on. That's not the same as what happens in a connect. And in a connect, it's simply you issue something in the beginning and it passes through from that point on without decapsulation, without anything.
The exact protocol used for HTTP Connect is indeed substantially different. And if you're looking for a protocol analogy, it's much closer to SOCKS.
I think that we need some more discussion on the list. Speaking as an individual and not as chair, I think we need some more discussion on the list.
This seems like a great beer topic as well upstairs.
I mean, could we try to take a consensus call? Or I feel like we've talked about this now for 2 IETFs, and there's not been much missed discussion at all. So I feel like a lot of people have been following this pretty closely, and I feel like we'd be ready to make a decision here.
Decision to adopt it as a working group item.
Yes.
All right, I'm willing to do that now. Yeah. Yeah, fair enough. All right, so let's do a hum. All right, since we're a little over time, we're going to have to confirm this on the list, obviously. All those in favor of adopting the draft, please hum now. Okay, stop. All those that oppose adopting this draft, please hum now. It's pretty rough, but I think good enough to pull in. So we obviously have to confirm that on the list, though.
So I formally object to adopting that draft without enough time to actually discuss or get answers to
Well,
any of the security questions
that's
that were
why
raised.
we have to take
Okay,
it to the
so-
list, Colin.
Yeah.
And I'll take the roughness of the hum and the continued discussion as a direction not to insert anything in the transport draft at this time.